Good morning, everyone. I want to thank the organizer for inviting me to share the GCMD mission to decarbonize the maritime sectors today. Okay. So to start off, I think for those who are not familiar with GCMD, I'll just run through a couple of slides so that you know who we are. And I'll also share a bit more in terms of how we see the maritime sectors, how to decarb, and the type of projects that we're doing to share with you how we try to help the sectors. Okay. So for GCMD, our mission is straightforward. We want to help the maritime industry eliminate GHG. And you ask a question like, okay, let's do it. How do we do it? So we do it by a few ways. By shaping standards, because we believe for the maritime sector, standards are important. Otherwise, when there's too many configurations, the ships cannot connect to the correct fuels, to the correct ports, and the correct cargoes. Okay. The other thing is we also do so by deploying emerging solutions, piloting them, financing those projects. And those are very important because when you start to move from TRL 6 to 7, when the project goes into the water, it becomes very expensive and it requires a lot of stakeholders. As later I will share with you a couple of slides to illustrate that the problem is not something that you can solve alone by a single solution provider. You need to solve together. Okay? And we do so by fostering collaboration within the maritime sectors and beyond the maritime sectors. So how do we do that? We add value through pilots and trials. I want to emphasize that for GCMD, we are very focused on pilots and trials. As much as you have seen studies, the studies are done to support that. And it's required that we need to have that domain and technical expertise. We are also a non-profit organization, so we are a neutral convener for the stakeholders. With the funds given to us by our partners, we are able to do agile funding for studies, and also co-funding for bigger projects. And in the project that we do, in the construct, we also involve the regulators and policy makers in the very onset. We believe these are the key elements for to have a successful pilot and to move the needles. Now, this is a very busy slide. It gives you a summary of our projects over the next 5 years since our inception in August 2021. I will share more on the first three, which is ammonia bunkering, assurance for drop-in green fuels, and shipboard carbon capture. We do have a latest initiatives on energy-saving technologies to improve fuel efficiency of ships. That is still in the works, and we will share when it is ready. And the bottom row, it shows the various partners that are supporting us. To date, we have 25 partners, spanning the original founding and strategic partners, impact, coalition, and knowledge partners. So you can see that our center partners actually span a very wide spectrum. And this doesn't include the partners that are supporting our projects, which is more than 80. So this slide provides another perspective of how we see a multi-fuel future. I think I've shared by Joe just now that that the future has many scenarios, and you will transit to the renewable era. But if you look at now, if you start to dissect the fuels, we're using the distillate, the residue, and LNG, which is the ambient and cryogenic. So 1, 2, and if I want to put fossil LNG, it is not yet there in terms of green. Now, people are starting to use biofuel, the blends, methanol, followed by the green methanol or the blue methanol, you know, put it, and the bio LNG, followed by then the ammonia from where the hydrogen is from renewable or from carbon capture source, which is blue hydrogen to blue ammonia. And then finally, we have the ammonia, hydrogen as a liquefied form. So we can see that the transition is moving from fossil-derived to biological, and then subsequently renewable-derived sources, accounting for the entire life cycle with many permutations. So that is a challenge that we are talking about here. So this slides actually shares a bit of the findings of our ammonia bunkering safety studies. This was done by Lloyd Register together with Savanna Jurong and the Singapore Maritime Academy. So in short, I think we base it on the Singapore scenario as a bunkering hub, and the takeoff will be around mid-2030, about 2 million tons per annum by 2035. We also have identified over 400 operational and locational risks across 4 concept designs and 3 locations in Singapore, and all are considered low and mitigable. And as a result of these studies, we also have the guidebook that we incorporate into the training curriculum for the Singapore Maritime Academy. And the first course was actually conducted in March this year. And the learning, we also have been shared with the Standard Development Organization, domestically and internationally, to help to shape the standard to say, how are you going to go about doing bunkering, ammonia bunkering specific? It's not just as a cargo. And we also been working with the Oil Spill Response Limited, in this case, to develop an emergency response. You must understand that when you carry such a fuel in a huge quantity, you must also be prepared to say, if there's a spill, what happens? So the emergency team in the respective ports must be ready to address that kind of situation. And of course, all this is to help to prepare ports like Singapore for the first ship-to-ship transfer, to help to gain confidence and competency. And that also applies to other ports. So this slide shows the partners involved in this study which have completed. And you can see there are 22 study partners which was assembled by GCMD, starting from producer to the storage, to the barge suppliers, barge operator, terminal operator, vessel operators, owner, ship design firm, consultancy firm, and the fuel quality and testing. It gives you a sense of, to do such a study, we need to involve so many people to get a very holistic view of how we can get the molecules from end to end. And we also have roped in, we have a link where industries can sign up as an industry consultation alignment partner, and there are more than 130. And we also consulted 8 regulatory agencies. So this was what we did for the studies. Okay. Next steps, we will work with industry partners and regulators to continue to move beyond studies to actual pilot. So to do that, we need a regulatory sandbox. We need to really develop the emergency response procedure. It's not just on paper. It needs to be done. Otherwise, we can't do it. And validate the various hookup arrangements, like shore to ship, ship to ship, in port, what happened in Anchorage. And I think Joe also mentioned SimOps. These are the things that is very challenging, that we need to really dive into the detail to say, if we do it, and if you're going to do it, what should we do? And that process, I think, will help to build confidence. And we will also refine and update the draft guidelines, which is right now being in the works. So that's the next steps. Next project is about drop-in fuel assurance framework. Now this project started off with a question that in the future, when we have a lot of biofuel blend, which is the first slides I show of the fuel transition, a lot of the green fuels will not be available in huge quantity. A lot of assets will be current. So you have seen biofuels, maybe bioLNG or biomethanol coming into the picture in limited quantity, in which then you need to, in some cases, need to physically blend it together. Now, how would you know, the ship owners who buy the fuel, that you are getting the green product that you are buying? For example, in HVO and MGO blend, can you tell the molecules of HVO once it's blended beyond the paper? And similarly for other bioproducts. So this project started off building upon what we know today for bunkering: quantity, quality, in addition, abatement. So once you take abatement into question and take life cycle, you need to start to track the fuels from origin all the way to user, which is very important, okay? So how we did the project, we actually constructed in such a way that there's 5 supply chain using used cooking oil, methyl ester, with high sulfur, with low sulfur, B20, B24 in Singapore, also at Singapore Port. So we completed supply chain 1 and 2, you have seen in our press release. Also supply chain 4, which is HVO, MGO at Port Rotterdam, B30. And we are in the process to execute supply chain 3 and also supply chain 5 in this case. CL is crude algae oil. We are exploring that as a combination to look at the future biofuels with greater potentials. So that's the current status of this project. And this is the ecosystems of the partners around it. Some of the stats above. So for these projects, the way we did it was we work with the fuel purchaser, which is the most important, the demand driver, together with enabler, the people, the technologies and the tracers, and engine OEM, and the test labs, which is very important. We need to make sure that whatever fuels that we're doing, in addition to being able to work, you also comply with the quality. So we have long-run degradation tests. With this group on the right, then we engage the upstream supplier in terms of what are the fuels I want to buy under a BAU scenario, but then we put in all the traces, all the various measurements and various tests to collect the data across the entire supply chain. So this project will be completed next year, so then we will share the reports. Shipboard carbon capture. I think we should say green fuels will not be available. A lot of the fossil will still be around. Even the future fuels will also have a carbon bond like methanol or LNG. So how do we help the world to decarbonize, the maritime sector to decarbonize? Carbon capture is one of the technologies is used by land-based, and the shipping sector is also saying that, can I use this technology too? I'm not going to have enough green molecules, okay? And if I have a lot of fossil, maybe I can do the same as a SOx scrubber. I capture it, then I kind of offload it and manage it accordingly, like utilization or sequestrations. So in these sectors, in this particular project, we try to answer the question on, can this be done on board the ship? Is there sufficient energy? Is there sufficient onboard space? And what are the challenges involved in putting a system for different fuels? For example, let's say it is a high sulfur, you need a SOx scrubber in addition to it. The type of emission coming out determines what kind of technologies and the difficulty of how you capture the CO2 beyond what we know today as, even for green fuels, you need to customize the systems in such a way that it can capture. And the bigger problems will also begin then after you capture. What do you do with that huge amount of liquefied CO2 on board the ships? Do you store it at medium pressure, low pressure, in ISO tank, in Type C tank? For different ships, where do you put it? And when you reach a port, how do you actually offload? At anchorage, at berth? So there are many questions to be answered. And that's not the end. After offload, that's not the end of the problem yet. That molecule, CO2, need to be either properly utilized in a permanent state or sequestered. So if you capture 100 units on ships, you don't actually capture 100 because when the end 90 at the end, that is the amount that you actually sequester and capture. Of course, there are some rules and regulations you can say in terms of custody transfer, but these are things that we need to understand more. So for this particular work stream, we started off with the onboard capture site with the attempt to say, okay, let's try to do this from end to end, starting with the ships. So these projects with Project Remarkable, with OGCI, Stena, and of course various players and various industry partners supporting us. We started off with three phases. We start with first phase, which is concept design and feed, which we are wrapping up this year. Okay, so the attempt is to understand if you're going to build such a system on an MR tanker, and we captured at 30% and 100 kg per hour, with the attempt to say it must cross from port to port, how can this be done? So for this project, we have done it based on the generic technologies so that we can share the results as much as possible with the industry when the results is out for phase one. And then there's a gate review to say, okay, does this make sense? Are we ready to move to the next steps? Can it be installed? If installed, then can we offload? So we are at that stage where we are going through a review to understand, do we want to move to the next steps after we complete phase one? Okay? We don't wait for this project to finish. Concurrently, April this year, we also awarded a study to Lloyd Register and Arab. We asked the question, okay, assuming I got captured CO2 on the ships, how then should I do the offloading? Simple questions, but when we dive into the subject matter, we realize, hey, actually it's not so simple. You know, this is not on the land to a tank to a ship. This is on the ship where a busy port, you got many ships coming, and many small ships go and pick it up and transfer and aggregate to a shore tank. And some instances, the ships are actually doing their cargo offloading. Then you need to simultaneously offload the liquefied CO2. And I'm just talking about one form, liquefy. I haven't talked about the carbonate. I haven't talked about the different types of carbon capture technology. So we ask ourselves, in this space, let's say we have this pathway moving forward to the shore utilization. How should the shipping sector best do this? Now, it's an important question because, remember I mentioned standards? Can you imagine there are 1,001 ways of doing this? Then it is impossible for ship owner to say, what solution do I deploy? The ports will say, hey, how are you going to give it to me? So we hope through this study, the shipboard carbon capture provider can unify in terms of what type of storage means should I design in such a way that the port knows that there are 2 or 3 options at maximum that I can receive, and standardize the infrastructure investment in that aspect, including the LCO2 receiving vessels, a bit like the bunkering, but in this case, you take out the CO2. And there's also the question whether it is considered a feedstock or a waste. It matters a lot because it actually determines whether you can offload into that country or that ports, which will enter into the national accounting. So the scope is written below: onboard capture, onboard storage, the concept to safely and accurately offload shipboard CO2, the readiness of the infrastructure is important. It's a network that you need. It's not about I go to point A, then I cannot offload. I go to point B, then I can offload. The consequence is you're going to carry captured CO2 around the world. And that will have its operational constraint and economic penalties in terms of cargo space and cargo weight. Okay? And we also want to understand what is the CapEx and OpEx model for the scenario in this case. If you're capturing at medium pressure or low pressure, how should the receiving infrastructure manage that molecule? And if it is for a particular application like concrete quarrying, greenhouse, or aggregation to a sequestration site, what is the quality of the CO2 that I need? It matters a lot because all this will impact when you start to aggregate and store in bulk and manage that. And more importantly, what are the gaps in terms of custody transfer, competency standard, and regulatory approval? Will the port receive, if it is a waste, will they receive the waste? And it's not just any waste, it's a waste that may potentially increase the CO2 accounting inventory. And of course, then we'll validate that finding with the industries. So again, we take the same approach. We assemble a group of stakeholders to support the consultant for this 9-month study, starting from LCO2, solution provider, port regulators and observer, port and storage terminal, vessel owners and cargo owners, shipyard vessel design, and enablers. So all in all, we have about 27 partners helping us, not including the industry consultation alignment panel, which of course you can go online and click on the link. Then we evaluate whether you can be part of this study. Okay, so right now we are now in the month of October. This study will complete by January or first quarter next year. So we hope to share the results sometime around second quarter next year when we polish up the study. Okay, that's my last slide. Thank you.